Hello, welcome to WEBfactory's i4SCADA Studio tutorial series. In the last video, we've explored the configuration of industry-standard connectors inside i4SCADA Studio. Now it's time to talk about the Modbus connector. Let's start in i4SCADA Studio by adding the Modbus connector to our SCADA server. The Modbus connector configuration panel is opened in the lower part of the Studio window. It provides two ways of configuring the Modbus connector, either by creating a new configuration or by importing an existing one. Let's start with the new configuration. Use the New button to add a new Modbus gateway. The dialog allows us to select the protocol used to connect to our device. This also sets the corresponding frame format for our Modbus device. TCP protocol for devices connected over Ethernet. Here we need to provide the IP address and the port of the Modbus gateway machine. Or RTU protocol for devices connected on asynchronous serial data lines. In this case, you need to set up the parameters of the serial interface of the Modbus gateway: port, baud value, data bits, parity, stop bits, and the handshake. Here the port represents the COM port on the PC running i4SCADA. I'm going with TCP for my Ethernet attached Modbus gateway. The configuration panel shows our new Modbus gateway under the Modbus connector parent. The table area of the panel displays the Modbus gateway specific properties, starting with connection type, prefix, diagonal signal, max digital and max register values, the number of concurrent transactions, and of course, the communication protocol properties for TCP, which is used here, and RTU, which is empty in this case. If you're not familiar with the Modbus protocols and properties, check out our article on Modbus configuration linked in the video description. Selecting our Modbus gateway reveals the Modbus devices view, which is empty. Let's add a device to our gateway. The right side table shows the device's parameters: prefix, which will be used as a signal prefix when importing its signals in Studio, unit ID, and the byte order settings. The 4 byte order settings allows you to set the byte orders for 32 and 64 bits integer values, as well as for 32 and 64 bits floating point values. You can read more about Modbus byte order in the article linked below. Modbus device signals are defined by data stored in the device's items: coils, discrete inputs, holding register, and input registers. Selecting the Modbus device in the tree menu allows you to access the polling period setting for each of these items. The coils and discrete inputs hold on and off values that can be read and written bit by bit in case of coils, or only read bit by bit in case of discrete inputs. Holding and input registers hold numerical values that can be read and written word by word in case of holding registers, or only read word by word in case of input registers. All the data in the Modbus device items is defined by the name and Modbus address properties, with holding and input registers data having two additional properties: type and array item size, used when the type is set to array. Each data can also be marked as unreadable. Now that we have data in each of our Modbus devices items, let's browse the new Modbus connector and add these data as signals in i4SCADA Studio. The data we've just defined is available for import in the Browse Connector dialog. I'll select it all and add it to a new signal group. And just like that, the Modbus device signals are available in WEBfactory i4SCADA Studio and can be further used in your visualization projects. Thanks for tagging along with me in this Modbus setup in i4SCADA Studio. Keep an eye on WEBfactory's i4SCADA playlist for more in-depth configuration videos like this one. And don't forget to check out the detailed article on Modbus configuration available in the video description. Until next time, stay safe.